welcome back to the STEM Shed. Today I'm going to go over a problem I've seen before. I saw in the SAT book. It's a pretty good little problem. Again, SAT likes to trick you a lot. They try and get you to do things you don't have to do. So this problem here is, it essentially gives you this. It tells you have a triangle, P, Q, and R. It tells you that the lengths here, PQ and PR, are the same. They give you the lengths for QT, for TS or ST, and for VU. Oh, let me turn this music down. All right. And then they want you to know what's UR right here next to the blowtorch. Okay, so how do you solve this? Well, I guarantee you, and this one was a tricky one. It actually took me a little bit to figure out because I was overthinking it. You know, my first thing was like, okay, so I have this here. I have a right triangle, so I know what to use, Pythagorean theorem, and I chose 3 and 4 because I think it illustrates a good rule called the 3-4-5 rule. People in construction understand that. So, which basically, if you have c squared, remember the Pythagorean theorem is a squared plus b squared. Well, I want, you know, all this magic right here takes principal root because you can't have a negative distance. A squared plus b squared. If you plug 3 and 4 in here, whichever order you want, doesn't matter, is equal to the square root of 25, which is equal to 5. So it doesn't matter which order you go in, but either way it gets 5. So I end up doing like, oh, okay, 5. But this didn't help me at all because it doesn't matter about this distance here. All right, so this was useless for me to do. It's a time waste, and I wasted time trying to do that. Then I realized that this is the key part right here. PQ is equal to PR. This signifies that it is an isosceles triangle. Isosceles comes from the Greek roots isos, same, and skelos for leg, same leg. That means this distance right here is the same as this distance right here. They are equal. That's great. This makes life way easier because using Pythagorean we might find this 5, but we don't know what this is, we don't know what that is, and we don't know what this is, we don't know what that is. We're wasting time. So what this signifies to us is this is a ratio problem. It's a ratio. That's all you got to worry about is a ratio. And honestly, what's great about this is it doesn't even matter which way you go about it. You're going to get the same answer. So you say, okay, it's a ratio. I'm going to say 4 over 2 is equal to 3 over x. All right, we're going to do a little switcheroo. X on this side, x on that side. Cancel, and then we're going to flip it over. So we get x is equal to 3 times 2 over 4, which is equal to, that comes 2, this comes 1, so 3/2, or approximately, or actually is 1.5, I think. I'm not doing it in my head right now. If I'm wrong, correct me. Alright, so 3.5. It's a ratio. That's your answer right there. You don't have to do it anymore. You're done. Alright, so what's up next then? Alright, and let's explain why this works. Alright, oh, and yeah, your length would be 3/2. 3 over 2. I know, Ben, hold on. Alright, so it comes down to this, and think about this. Say I drew this triangle here. Now this is a very exaggerated triangle. Alright, and I drew this length here, and I drew one down here. So this distance right here, this is longer than this one. Now let's go back to here. If I took this here, I expanded it over to where it hit the same spot here, I could pick this up, flip it around, and it would match this right here because the ratio would be the same. This one right here, if I brought this over and matched the height, I'm going to say it's approximately that, I would pick this up, and let's say this will look like this, roughly. Well, if I took this up and flipped it, this will look like this. It doesn't matter the same height, your ratio changes. So you won't be able to solve the problem that way. And so this is how this problem was. It's a ratio. They're trying to get you to overthink it by giving you all this. You know, and that's all it really was. There's nothing else to it. This is a pretty quick problem. The big key here was the PQ is equal to PR. It's isosceles. And even if you have an equilateral, which is isosceles triangle with 3 equal sides, isosceles has 2 equal sides. Or more, and then I don't think it would help being equilateral. But I wasn't going to really try and solve it. But I hope this helps. Thank you.